Hello everyone. Today I'm going to explain how to read a floating point 32 number from a string. So this video comes after another video where I discussed how to read an unsigned integer and a signed integer from a string. So if you haven't watched that video, then you should watch it either now or after this video, since we are going to use these functions that were already presented. So I have this float 32 from string function here. So I'm giving a string and its address is in RSI. In RAX will be the result as a floating point 32 number. In RSI, we'll have the position after the number. So RSI will be incremented with the number of digits, the decimal point, and the sign, and everything that was read as part of the number. So let's see what's happening here. First, I'm starting by saving the registers on the stack. At the end of the function, the registers will be restored, so you can see it here. I also have a temporary place here which stores floating point value. So now let's take a look at the actual algorithm. So we start here. I'm calling int32 from string, which reads the integer part. So from the previous video, in this function, I'm also sending RSI as the string, so nothing to do prior to the call. And this function will return in RAX the number, including the sign, and RSI will be advanced after this number. So now what I'm doing here in R9, I'm storing this integer part for later use. Then I'm storing in this temporary location that I shown you this integer, so RAX, and then I'm loading this into the floating point unit, and this automatically converts it to a floating point 32 number. However, this is only the integer part. So now remember, RSI was already advanced after this integer. So I'm checking to see if we have a decimal point here. So it's possible that we have actually an integer which is being read as a float, or we have a real floating point number with some decimals. So if we don't have a decimal indicator, this dot, then we jump to the end, and let's see what's happening at the end. So this is the end, where the floating point number in ST0 is stored back in this temporary place. And remember, at this moment, it's converted to a 32-bit floating point number. And in EAX, we load this floating point number. So the number returned here is 32 bits. We also restore the registers and we return. And that's it. Now, if we have this decimal indicator, then we also need to read the decimal component, the fraction, and we need to combine the integer part and the fraction part and get a complete number. So this is happening here. So I'm first incrementing again RSI, which moves it past the dot. I'm storing this location. I'm in R8, and I'm calling this unsigned integer from string. And again, in the previous video I've discussed it. I will leave a link in the description. So now RSI was incremented past the decimal part, and this was read as an integer. So what I'm doing here, I'm computing how many digits were actually read. So I'm subtracting R8, which is the previous value following the dot, and I'm subtracting that from the current RSI value, which is after the number that was read. So at this moment I'm storing first the rux, which is the number that represents the fraction. And again, I'm loading this in the floating point unit. So at this moment, we have in ST0 the decimals as an integer, but this was converted to a floating point number. In ST1, we have the integer part. Again, it was read as an integer, but it was converted automatically to a floating point number. So now in rux, I'm setting 1, in R8 10, and here I'm comparing RCX to 0. So if we reached the end of the loop, we exit the loop. Otherwise, we multiply rux by 10 and we decrement RCX. So remember, RCX was the number of decimal places. So basically, if we have 1 decimal place, then in rux we'll get 10. If we got 3 decimal places in rux, we'll get 1000. So we need to divide the content of ST0 by rux. And so that, for example, if we have say 0.123, we actually read 123, so 123. In rux we have 1000, so we need to divide this 123 by 1000, and we get what we want, 0.123. So now this is happening here. I'm storing again in the temporary location the content of rux. I'm loading it as an integer that gets automatically converted to a floating point number. So at this moment, our floating point stack will look like this. In ST0, we have 10 to the power of the number of decimals. In ST1, we have the decimals in its integer form. In ST2, we have the integer part. So we perform here a division, and we basically divide ST1 by ST0, and we also remove ST0. So now the floating point stack becomes ST0, the fraction part, and ST1, the integer part. So what remains now is to add these two parts if we have a positive number, or to subtract if we have a negative number. So this is happening here. I'm checking to see if R9 has the sign flag. And remember, we saved the integer part here for later use in R9. Okay. So if the number is negative, then I'm using f sub p, which will perform a subtract and also clear one position in the stack. If it's positive, I'm using f add p, which will add the fraction and the integer part, and again clear one position in the stack. So following either addition or subtraction, and now in the floating point stack we have in ST0 just the number, the complete number. So at this point we have reached again this done label here, where we are storing again the value in ST0 to the temporary location, and then I'm reading this temporary location into EAX. And remember, it's not possible to directly access the regular CPU registers from floating point operations. So that's why we need this temporary memory location. And that's it for this function. Let's take a look at a quick test here. So this is pretty much similar to the test I've used for the integer numbers. So I have here a number list. It starts with the unsigned integers from the previous video. Then I've added two signed integers here, and then we have floating point numbers either without a sign, with minus sign, and with plus sign. And again, we need some terminating character in the string here. I've used the space, but this can be other characters as well. And now the number of characters was increased to, the number of numbers, sorry, was increased to 10. So we have 10 numbers here. And we also have a buffer for representing a floating point 32 number as a string. And similar to the previous video, I'm calling float32 from string, so we read a number from the string. Then I'm converting the number back into a string, and I'm displaying the number. And a while ago I created videos about converting to string and displaying, and again I will leave links in the description. So basically we have a loop here which loops over the RCX register, which is initially set to the number of numbers in the string, and it simply performs this loop of reading number, converting it back to a string, and displaying it. So let's take a look at what happens. As usually, I have a very small build program that build script that compiles everything and links them. I also have a very short clean script here that removes object files, listings. So let's run it. So as you can see, it read the numbers in that string. You can see we have also negative integers, but they were converted to floating point. We also have with decimals, both positive, negative. So I hope you enjoyed this video, and don't forget to like and subscribe, and see you next time. Bye.